So thanks very much. Before I jump in, I want to say thank you to Marty and Frank and the whole network office gang for pulling this off. It's been great. I always love hearing these talks. I'm really in awe of everything that goes on in the LTER network. So site news, starting with the most important of all. After about 40 years, I'm pleased to say we now have a logo inspired by the humble Secchi disc. But more importantly, I'd like to welcome, we have a couple of new investigators. Dan Preston, who's an assistant professor at UW-Madison, and Gretchen Garish, who is the new director of the Trout Lake Station. She picked an interesting year to step into her first full season running a field station. And our past year, like other sites, we spent a great deal of time talking and thinking and writing a proposal. And what I want to do for this presentation is to just give one example of some ongoing and we hope future research that was inspired by some past work, and we hope future work. So long-standing area of research led by our founding father, John Magnuson, has been about how climate change is affecting ice cover on our lakes, and we've had a very clear long-term trend. We've lost about 40 days of ice cover here on Lake Mendota, one of our core LTER study sites. And you can see that all the extreme long ice cover years are far in the past, and all the extreme short cover years are all with us now. And this leads us to really wonder, when is it that we'll see a winter without ice on Lake Mendota? And in fact, John is still involved in this work, but has passed the leadership on for ice dynamic research to NTL Sapna Sharma, and she has led a charge to address this question and sort of predict when lakes will go from permanent winter, from having annual winter ice to being intermittent. And the orange band in this map is where lakes are currently intermittent with their ice, and each progressive band is where that intermittent ice band will go to for lakes as we go 2 to 3.5 to 4 degrees warmer in the future. And the NTL lakes are somewhere in that purple to yellow band. So we expect that to have this abrupt shift in our lakes to be headed toward us in the future when we don't have reliable ice cover. Now, in addition to this directional change in ice cover, we are also seeing a change in the variance in when ice leaves the lakes in the spring. So you can see here for these different lake districts in Wisconsin and Minnesota, basically ice off dates have become very unpredictable across a very large number of lakes. And so inspired by these trends, we are asking questions and our hope to continue to ask questions, first of all, and simply, what goes on in lakes under ice? This is a period of time that limnologists often ignore. And really, what are the consequences of a shorter and more variable ice cover for lakes? Now, sampling in the winter is not done much because it is difficult and dangerous. And happily, Hillary Dugan and Noah Lottig, shown here, have been leading the charge on addressing this question through partnership with some awards that they have received, as well as LTER, in developing additional ways that we can sample lakes at this time and find out what's going on under ice. This has included developing some really reliable scaled down autonomous buoys that can be put under the ice all winter long. And then Hillary and Noah are working on an experiment with, I think, their new favorite toy, the Argo, to manipulate the timing of ice out in the spring by removing the snow here and trying some new measurements. That is an eddy flux tower in the background that we hope that dropped into the lake when the ice went out to measure the flux of CO2 and methane that came out of that lake when the ice finally did break. And of course, as an LTER site, the other tool that we have at our disposal that is really critical to understanding these patterns of what goes on under ice and what are the consequences of them over the longer term is our long-term data. And really sort of looking at those data, we can see that there's a lot of variability that happens. We have some lakes that may be very well oxygenated throughout winter, as you can see from this graph on the left, to having in another winter just completely losing their oxygen by the end of winter, and which has huge consequences for metabolism, for biogeochemistry, and of course, dramatic events like fish kills. So the question then becomes, what controls those? And then something we hope to be pursuing in the future is this issue of phenology. It's not been a theme that limnologists have embraced very widely. And given that we have this ice out variability, we want to know what the consequences of this may be. And we can see here 2 years on the upper right, where the ice came out early and late, a difference of about 53 days. And this had big effects in terms of what zooplankton were present there. It took a while for the late ice out year to catch up in terms of the diversity of the community. And then some fish species like the walleye seemed unaffected by it, whereas others, there was very responsive to the difference in ice out dates, and leading us to ask questions about phenological mismatches that may show up and how they may vary from lake to lake or from one link in the food web to another. And we hope to be pursuing those questions in the future. And as a final addition on this, this work will involve not only NTL lakes, but also we've really been able to bring in a partnership with the Wisconsin Department of Natural Resources. They are sort of making a comeback after some budget cuts. And this will be facilitated by a new PI as well, Greg Sass, who is the fisheries research team leader and oversees a set of study lakes that are up the road from us that have fantastic fish data that is over 70-year records. And they have slowly been trying to also incorporate in core measurements mimicking our own. And Greg will be a critical part of this phenology research going forward, and facilitating the transfer of science between NTL and management in a smooth and, we hope, helpful way. So that's it. Thank you very much.
Thanks, Emily.